So we're starting. All right. Hi guys, good evening once more. Thank you for joining us in our autumn Ansible Meetup. This meetup, we get together to hear Daniel and we have Joe with their talks about how to use Ansible. And yeah, I give it to you guys.
Hello, everyone. So today we're going to have a look a bit at how we can actually develop our own Ansible modules with Python. And the main goal of what you can get away from this talk is first to show you how a development setup would look, to give you a bit of a look, okay, how do I make my own module? What kind of a development environment can I set up for myself? And the second thing would be to show you, okay, how do I take a real life application that might not have an ideal API, that might not have everything that we would have in an ideal world if we're just developing something from scratch. How do we deal with a real world application where I just have some software, I want to manage it, there's no automation existing for it, how do I develop my own automation, and what kind of problems is this solving, what kind of environments I work in, and what kind of an approach is this. So I work on a development team, which is about 6 developers. And what we do is we also cover a lot of the operations side. So we are very much involved in both. We are very much developers, but I am mostly handling the, you could call it the DevOps side. And what we're going to look at is, okay, we have an environment, we have a company with a lot of stakeholders, a lot of people in the organization, a lot of moving parts. And we have some use cases where we need to manage things and we need to bring them under control, and we would ideally follow a workflow like we follow for everything, which is keep it in Git. And what we're going to look at is some ideas how you can take an application that you have in your organization, but slowly over the years builds up some some legacy, builds up difficulty in managing it. How can you take it, wrap it in something that would be a standard development workflow, just kind of use it to align things. So that is very much the idea behind that, because a lot of the time what we have is we have an internal deployment, right? And we have it pretty well figured out now how to take a deployment of an application. Let's say it's a random web application. What we'll do today is we'll take an inventory system, something simple. It's an inventory system. You put in models of some hardware that your company owns, and you keep track of it. And we are very good at the moment with the existing tools to automate how we deploy it. We can test the deployment with tools like Molecule. We can see that everything works. We have it under control there. The problem is when we start operating it. So I have an application, I have all the code, I deploy it to production, right? And the first issues that we usually hit is, well, the application has a web UI and a ton of settings that I cannot track anywhere in Git because the application author didn't expose that. And how can I bring that under control, right? Like how do I avoid a situation where, let's say, we have 5 teams across 5 time zones using it, and they all have admin. So what will happen is this will diverge. There's no way around it. Like, first, of course, people are going to edit, people are going to change, people are going to tweak, and eventually my application becomes less and less consistent because I have no way to review those changes, no way to stay on top. So that is something that we are facing a lot because the organization I'm at, we have very few global teams and we have a lot of local teams. And then we have the problem that if you're not even in the same time zone, if you have 1 hour of overlap, how do you let people discuss things? How do you let people keep track of them? And one of the things that I'm looking at is, okay, how do we solve it? For here, we all pretty much have the same instinct. Let's just put it in Git. But if I have an application that does not want to be put in Git because there's the author of the application just said, okay, you can just throw in whatever you want, do it in the web UI. The way we can solve this is we can develop our own Ansible modules, use the application's API, and say, okay, now I have Ansible modules. Now I can version my configuration. I have I can have people review it. I can have the stakeholders from technical teams involved in the discussion, and they can actually see the change set. It's not just something that happens in a meeting. It's something that happens on a merge request, like any other change we would do. This is what we're going to look at today. And after a little bit of an introduction, we go to a live demo, which never goes wrong. Nothing ever happens. It's always fine. So what we're going to do is we're going to hop into a development environment with an example web application. All we need to care about is it's an inventory system. We need to track things there, and there are admin settings. And the goal will be to show how with a little Python, I can create Ansible modules which will manage all of this. So if I have a big distributed team, I can ensure that we're all in sync, that we're all working together, and that we all see the changes that we're making. So now I will switch over to that. And we can like this.
Can you?
I think
You rejoin, not in companion mode, just as normal user.
as a normal user, sure.
Because the companion mode doesn't stream.
Sneaky.
Now it gets better.
Okay. Oh,
Seems to work.
perfect.
Okay.
All right. So first things first, together with this demo, I will share out at the end of the presentation a public repo on GitHub where, wait. Oh?
Can you zoom in?
Can I zoom in? I will zoom in once I start showing it off, no worries. So I will share a public repo with you on GitHub. I tested it on macOS and Linux. I do not own a Windows box. I'm super sorry about that, but I can guarantee it works on Linux. And you have make file targets where you can just say, make development, you get a development environment, you can test around. And all you need really is Docker on your machine and a Python interpreter, and you'll be all set. So on to the live demo. I will first, what I'll do is I will reset the dev environment. Oh, come on, where's my README? Yeah, I will hop in through here. So let me full screen this. A lot bigger. So together with the repo, we have a development environment. It's essentially all wrapped with Docker Compose, and then afterwards we bring up a database that's all done for you. All you need to do is run make dev. I already ran it for the sake of time, but I will reset the state of the setup so that we are sure we're clean. There's a make file target, which just
That's an arrow.
there we go. No worries. I didn't run my Docker containers. I lied. Okay, we do the full thing from scratch. I bring up my little application, and now I have another target, which what it does, it sets up the DB for you it's a clean install. All it has is we have some API keys baked in. Please don't use it in your production. This is for your laptop because those are public on GitHub. They're just for this demo. So please don't use it in production. I feel like it's a standard disclaimer. So what this does for us is it brings up a little container, and what we get is a web application that it's called SnipeIT. It's a very basic inventory system, and the credentials, you can find them in the README. It's admin and password, as secure as it gets. And from here on, you can see, okay, I have a web application, right? And the challenge that we ran into when we were running it at our organization is there's a lot of settings you can add here, and all of those settings are untracked. And over time, you see more and more of a mess because it's natural that humans make mistakes. You don't have a second pair of eyes. Then somebody's scared to remove this because, well, it must be there for a reason, and you just kind of keep building up this legacy debt. Now, this is a small application. You can have way bigger problems when it's something that's more important, to your production and inventory system. But here, for example, we have categories, and we want to make sure that whatever we have in here is consistent. And there is no Ansible module for this, or at least there was none before this demo was created. And now what I'm going to show you is how you would structure Python to wrap around all of that functionality into a module. So in the repo that we have, and let me just, yeah, there we go. Big enough? Okay, let's see. So we have a little structure. We've got some structure that Ansible expects. It expects a plugins directory. That's where Ansible holds anything it references. So we can hold some utility code there. We can hold Ansible modules there. This is where everything that Ansible cares about exists. And anytime you develop a collection, you would see a very similar directory structure. If you go into the public ones, the ones that we all use, like Ansible Community, General, Ansible, the AWS collection, you will see the same structure. This is also useful if you need to troubleshoot a weird issue. And what I did here is I have a Python file, and in that Python file, I define that if this is called directly by Ansible, same as I would call it from the command line, if this is the main program, execute my module. And what it is expecting is it's expecting that in my code, I will eventually call a predefined function that comes from Ansible module. So what I'm doing is I'm importing all the way here from Ansible's Python modules. I'm importing Ansible module, and this is what I pass all the information to. This is basically the meat of the potatoes of it. It handles most of the work for me. And what I'm doing is I make whatever changes I need, I do whatever idempotency checks I want to, and then I return a result. So we are going to dig into how exactly that happens. In the structure here, we have our actual module code, which is just the logic, which is what we care about. First, we define some arguments. So let's say I have asset tag, snipe URL, API key, and this is a dictionary of saying like this is the argument I expect. I expect an asset tag. It must be a string. It is required. And how this translates to actual Ansible is if I have a little playbook, and here I am calling this module. Here I am passing those arguments. So those arguments we pass to Ansible. That's where we define them in the Python code. We have a dictionary which tells us exactly, okay, what is this? What am I passing? Is this required? And that's where Ansible will do all the checks for us. It will check if the type is right. It will check if we passed it or if the user missed to pass it. It will inform the user. So this is how it gets all glued together. So once I define my arguments in this structure, it's all of this, by the way, all of those little conventions you can find on the Ansible documentation. It's linked in the README of this repository. So if you need to look up things like, okay, how do I pass those args? You can not just go by examples, but there's also a well-defined set from Red Hat of what this should look like. And then I define a result. So what I do is usually I default that I didn't change anything. I tell it I didn't change anything because I assume that I will check if I did perform a change, and then I will flip it over. So I will just run every function that could change something, check if I did make a change, and that's how I enforce the idempotency. So that's the way in Ansible, if I run the playbook, what Ansible will do is it will tell me, did I make a change? And if I did, it will just tell me the state that you tried to enforce is there, nothing changed. But if I do actually try to do something and it tells me, okay, here's what you changed, that's a useful piece of feedback. So if, for example, if I have a server and I keep updating one config and it keeps telling me it changed, there might be someone else messing with that config. So that is kind of why we really want to keep track of this and make sure that those checks are in place. And the way we enforce them is further down in the code. First, I'm initializing this Ansible module object. What it is doing, this is doing all the Ansible magic of making sure if it errors, it will be passed to Ansible cleanly, giving it the arguments. And I also pass this little thing called supports check mode. Check mode is when we run Ansible and we can tell it to do a dry run. So we can support this in our module, or if it's too complex, sometimes we have to omit it. And what this is really useful for is I can make my functions support this, and I can say, Ansible, please tell me if I would have changed anything, but I'm confident it will not perform any changes. So I can just see, did something, are we going to do something? Are we in the clear? So that is the meat and potatoes of this. That is like how we define what it expects, and then we just execute code to perform the changes. So all we're doing is we're taking those arguments and we're going like, okay, what does the user want to do? And from here, it's our work to implement in whatever fashion we want how we perform that change. The way I like to do this is first I check if I have a deletion task of some sort, because that makes the code clean. If I have to delete something, delete it, get rid of it, and then exit. Just makes it really fast usually. So I don't have then too much of just code spaghetti, just going if else all the time. I just have one clean place where I go like, do I delete? Then I go ahead and do it. So here I'm checking if state is absent. So I'm expecting an argument from the user that tells me, do you want this entry to be present or do you want it to be absent? And if they pass absent, I run a function. And the way I structure this code is I expect every function to return true if it changes something. I expect it to return false if it didn't do anything. Because that way I can just keep checking that and just add it to my changed variable. I can say changed is false. And then if I have 100 functions, all good. If I have 100 functions, keep performing changes, I don't need to add any complexity. I just check, did this one change something? No, the next one. As soon as it flips to true, it will always stay true. And I will know that I need to report back to the user, hey, I'm performing changes. So this is a quick and dirty way when you're developing a quick utility for this to just make sure this is looking good. And here's exactly what I'm doing. I'm calling this function. What this function is doing is it is interfacing with the web applications API. We'll not bother too much with the API of this because it is a messy one. That was kind of why I picked it, because it's a real world example of how you can work around some things. But what we're doing is I have a function, and what this function will do is it will return true if I deleted the entry, and will return false if it already doesn't exist. So that's the piece of feedback that I give to the user. Did I delete something, or was it already not there? So that's the whole mechanism for idempotency that we have here. All I'm doing is I'm asking this inventory system, do you have this entry? If you don't, and I say, okay, I didn't change anything, it's already not there. So that is how we handle this. And then, okay, if we don't have to delete, we will have a bit more of an example here. Let me go back to the module code. There we are. If we have to delete, we delete, and then we exit. So there's this function exit JSON that means tell Ansible, I'm done. Here's my result. And the result comprises of two things. It's first, if you change something, and the second, more optional part is any arbitrary feedback you want to give to the user. So you can give them return values. You can just say, here's the name of the thing, or here's the date on which this was performed. You can pass anything you want, any data. We're not doing that here. Here we're just saying, did I change something? Did I not change something? And then we move forward, and we have some examples of the dry run that I mentioned. So I told Ansible, yes, I support dry runs here. So what I'm doing is I'm saying, okay, here's a dry run. If this is set to true, I will just pass this argument everywhere, and all my modules will do is they will just check if they will perform a change. So for every argument, for every function, I have a dry run argument, and every function is just enforcing idempotency if I run without the dry run. But if I run with the dry run, all it's doing is it's checking if it would make a change. So that's kind of the two ideas. One is just check if I would do something. The other one is enforce the state. And we keep moving. Now what we do is this is just making checks of what we'd expect. So I expect some things to exist in this inventory system. One thing it requires me to tell if I create an entry, what is a model? A model is, for example, MacBook Pro. So it expects that if I put something in, I tell it what it is. If I tell it a model I made this app 1 to 3, I expect it to error and say, hey, this doesn't exist, and give the user some useful feedback. Because otherwise, Ansible throws very, very bad exceptions, which are very hard to troubleshoot. So it's really good to try to handle as many of those as you can, because you will run into this that in production, a team using your module will ping you and go like, hey, we just got this error. Ansible said, error. And that's all it will say. It will just throw a very unpretty exception. It will be just something that went out of nowhere, just said, oh, something errored. It won't tell you what happened. It will be very, very hard to read traceback. So what we do is we try to just handle those. Here, if the user passes something that I don't want them to pass, I will tell them, hey, this doesn't exist. And it will make Ansible fail, and it will make report that back. And here, what I'm doing is I'm using this pattern. I mentioned that I have a little variable that says changed, and I just keep calling things. So I first call create entry, and what this will do is when it creates the entry, it will set this to true. If the entry already existed, it will be false. But then I move to the next thing, and I do the same thing. I just assign to the same variable a true or false value. What I'm doing is I'm saying run this. Oh, PyCharm is trying to be too useful. So what I'm saying is run this, and what this does, it updates some information, right? All it does, it performs an update on the application, and what I'm doing then is I'm saying if this returned true, say things changed, but if it didn't, check if we already changed something. I go or changed, and the only thing that really matters here is you need to pour your or changed afterwards, because how the Python interpreter will take it matters here. It will not execute your function if you do changed or my function. You need to do my function or changed. It's a bit of a just weird Python thing. If you're not developing in a day-to-day, keep that in mind. I did once have a test fail for me and just go like, what is going on? I don't understand. Staring at the code for a while and then going, let me flip this around, see what happens. And then I figured out it doesn't actually execute those functions if you do the wrong order here. And then I just save that result and I exit with it. So this is a very simple module of how you'd wrap an application. I have a lot of functions up top here, and all they are doing is they are taking those sets of arguments. I am passing them the Ansible module, because if I need to fail, if I need to raise an exception, I don't want to raise an exception. I want to use this fail function that it has, because Ansible then will present in a more readable format. It doesn't like when you throw exceptions in your code. It likes you to call fail.json, which is fail_JSON, which I have somewhere here. I need to get back to my Vim key bindings or I'm lost. Here I am. This is the way Ansible expects you to fail stuff. It doesn't like you to raise exceptions. It wants that to print it out to the user nicely. But here, what I'm doing is I'm mostly calling the application's API. And that is something that you can take any application, but you can also take something like a firewall. So there's a team of developers in the US who have a lot of pfSense firewalls. And what they're doing is they're doing the same thing as we're doing here, but instead of that, they have a code SSHing around to the firewalls and changing configs on them. You can use the same kind of principle to do the exact same things. But I'll be honest, that is usually way more of a complex development effort. If you have an API and you can wrap an API, that's the dream, because you don't have to deal with weird edge cases. I actually tried making some changes to those pfSense modules, and I see Ren was laughing very. He knows how this went. Long story short, if you want to test making changes to weird XML files and reloading an odd PHP application with them, you're not going to have a good time, because remember pfSense. So pfSense is a firewall solution where the front end is very much so in charge of the firewall. Like the PHP application is so tied into it. But if you make a config change, you actually need to call an endpoint to reload, which is why I hate it dearly. And I have to sometimes look at it, which doesn't make me too happy. But yeah, if you have an API, you can live in a nice world, we can all do all that. And now I will show a bit more of a practical example. I want to go into the code to give you kind of a familiarity with how we structure it. But how it looks, I have the application, right? And I need to create an entry here. I need to say I have something. To say I have something, I need to say define what it is. So I need to define something like a server. And to define something, so like let's say a server model, let's say I have a Dell XYZ, I need to tell it what category I think it is. So a category would be a server. So how would I use this practically, right? Let's say I have a team of a lot of people who I want to keep this inventory tidy because we all work with it. And let's say I have 5 sites using it. If I have 5 sites using it, that's a lot of IT people who can make a lot of changes. I would like them to make those changes. I would like to, have anybody on the team make changes, because ideally, if you have a good idea, you should be able to submit a change. So it doesn't matter if you're level 1 desktop support, you should still be able to say, hey, I want a new category for my stuff. But then you also want to keep people aware and keep people reviewing it. So what we could do is we could have simple little playbooks, like, let me just make sure I'm on the dev branch, about the things that can go wrong with a live demo. Okay, there we are. Where are the playbooks I thought I'd see? I have a little playbook called create entry that depends on the other playbooks. First, I need a category. So what I'm doing is I'm taking the API key from this dev environment that spins up here, and I am going to do Ansible playbooks, create. Oops, I am in the wrong directory. Playbooks, create category. And what this will do is call the modules that we're just looking at, and it will actually pass them those parameters. So it's going to say, here's my API key. I'm reading it from a file. Here's what I want. I want the category to be called a server. Here's the URL of my inventory instance. It's on localhost. It's the dev environment. And it's an asset, because in this inventory system, you can say I have a license for some software. I have a piece of real physical thing. That's all it's differentiating between. So now, one thing that is important before you actually try to run a playbook is you need to tell it, I'm in a development environment. Here's where you can find all the stuff. And I will make it bigger because I just realized nobody will see it on this tiny little terminal that I put up there. So in the README, there's a little quick one-liner that will tell you how you can tell it where all the code sits. There it is. So I have a little environment variable, and what it's doing is saying, here's my code, and Ansible, please look here, please use this code. That is what we will be using. Let me just make sure we're good. Yeah, Ansible library. So here comes the moment where it all goes perfectly right. Create category. And that is something unrelated. That's my bashrc. Ignore this. Okay, it says I perform a change. And here's an example of those return values I mentioned. If I look in my code, which is category, on this one, I am doing a bit more in the result. I am saying create a category and then get it and fetch its ID. So what this get category function is doing, it's talking with the API of the web application. This is not Ansible specific. It's just going fetch this, get the ID, but I'm passing the result. I'm saying result, and here I can just make up any field I want. Ansible only wants this change field. That's what it cares about. That's why it makes things red, yellow, green. But category ID is what is actually something that I just made up. And I'm saying, okay, pass this, return this to the user. And that's how I print out here, the server category has an ID of 2. And if I refresh here, I now have a server category. And that is one way I could create this. And then I could do Ansible playbook, dev playbooks. And I have another playbook here. Will create a model for me. And we'll say, this is an awesome 1-to-3 server model, the fastest one you can get, because it's awesome. And it's 1-to-3, so it must be fast. The only way you can make it faster is like with a car. If you paint it red, it goes way faster. We actually did it. We painted the server red, started going way faster. So this is another time where we can call a module. And this will create that model for us. Undefined variable API key. I did mess up. I'm looking this up from a file now. So that is what I get for doing a live demo. All right. So this is again calling that Python code we looked at earlier, and it's helping me manage my web application, right? So if I go to models in here, which I zoomed in too much and the developers didn't expect that, there we are. Awesome, 1, 2, 3. Responsive web development and all that. It's, they claim to support a smartwatch on this, if I remember. I saw it in the changelog once. There was like, we now support smartwatches. I think they gave up on this finally, but you can find funny things in GitHub changelogs. There we go. So here's my model, right? And normally we'd populate a lot more info there, but this is just how we can manage it. And now I have all my prerequisites, right? So I can actually create an entry. So I will go to all the entries. So this is where this web application keeps all the stuff. So if you had 100 laptops, they all show up here. And what we're going to do is just create something. And this is actually useful not only for management side of it, which is I think for me it's really useful because it helps you enforce a dynamic in the teams, right? You have a lot of teams working together. You can enforce a culture where, okay, we want people to look at changes together. We want them to collaborate. It's just the workflow the workflow guides people in the right direction. And it also helps to avoid weird divergence because one situation that seriously we're facing is we have 2 divisions where I work, right? And we have 2 divisions, they do 2 different things. And without going into the details of what they're doing, let's assume they were software developers. And one of them tracks time and has got a little thing that tracks time for them. And they need to put down the name of the thing they're doing. And they call it, if let's assume they're software developers, they would call it development. And there's, in the other division, they call it developing. And then they have 20 places with hard-coded values based on this. And now, we're sitting in a meeting together and going like, okay, how do we align this eventually? If you just grep for the 2 terms, we're all over the place. We're using reports, we're using this, we're using that. And people are making a lot of references. They keep making new references to different values. And that is one way you can avoid this. Because in a small organization, per game, it's a small organization. But the bigger it grows, as soon as it starts growing, because once it grows, it's too late, and there will be those things in place already. But as soon as your organization starts growing, it's really something to think about. How do I keep all of this, aligned? How do I keep not only the right culture of how changes are made, but also the right changes? And I think keeping this in source control as Ansible is absolutely one of the best ways you can do it. But here, this is more a practical thing. Let's say you have 2,000 servers that you need to all put in an inventory system because finance team asked you to. And hey, if I got an important report to generate per game to them, then you could use Ansible, get all the info, and create all your entries. And off we go. And we created them. And here, I've got a little thing. This is using the dry run capability we talked about before. What I did is I said, here, create a thing, and sets its status ID to 1. So it created a thing. And you can see it's got 2 statuses. And what those statuses do, they set a little label here. And it will be, it's ready to use, it's not ready to use. And this check mode that we looked at before, where we're checking if things are happening, but we're just passing dry run arguments to them, this is exactly what we're doing here. So if I comment all of the code above out, and I just run it in the pretend mode. So if I go here, I want the status ID of 1. This will report to us that it's about to make a change, but it will not perform it. Which status ID am I at? Let me see. This is status ID 1. Sorry, status ID 2, because it was running in dry run mode, so this didn't apply. So here it is. It's reporting, hey, I'm about to make a change. But in the code, what I'm doing is this is the status. I have a function to update the status. So if I search for status, update entry status label, this is it. So I go where I define this. And you can see that what I'm doing is I am saying, if I'm doing a dry run, just return if I would make a change. And this is how I'm getting that feedback to the user. And I can apply this to way more complex things, like would I restart the database? That's the kind of thing you want to find out. You can put that in your module, and you can control for it that way. And you can get a lot more advanced with how things operate. You can just say, okay, here's a list of changes, bump it to whatever team needs to approve the changes. You can do a lot of automation with it. And now I'm going to actually remove the dry run and just update this. So we're going to say check mode false. And check mode, this is what Ansible expects. That's how the module, the logic that they already have in place gets passed, so it knows where to change our node. And now we change it to false. So if I refresh, it will have tweaked it. It's no longer under pending assets. It's now a ready asset. And that is on the check mode implementation. And that is from the code, that is mostly it. And now what I'll do is I'll show you quickly how I would structure it in a production environment, because this is just simple playbooks to show here's how I'm calling my module. And I use them while developing, because the Ansible development setup, it's got a few things you can add here. This is just basic setup to show around it. But it wants you to run playbooks, and it wants you to mess around with things. It is more of a dirty hacky thing. It's not something as well established as you would have in Python, where you have a million ways to do things. Here, generally, you want your own little dev environment with dev environment with whatever you're trying to change, and you want to run playbooks against it. That would be the simplest way. What I recommend is to try to put some time and put a little container which you can consistently pass to your team, because if you have a workflow like those poor guys working with pfSense who cannot just have a container do, which it's not their fault, it's pfSense's fault, then you will need a big development environment that is very hard to ship to a developer, and it takes more time to onboard. You need to know how do I reset this dev environment. The best I could come up with when I was messing with pfSense is to just spin one up on AWS, because but you still need a full-fledged BSD instance, which is a giant pain. But if you have the option, a little Docker compose file, a little make target, and just say, this is what I expect on your system, run make dev. Off you are, you can write code. It really cuts down on the time that it takes to onboard people onto the team, and help them get running. Which on a lot of teams it can be a long process, and I think that's one place where people really underinvest in making sure that the devs can come in and quickly get moving through the code. But yeah, so how I would structure it in production actually is I would usually have a playbook called manage something, and I would say I am managing my Snipe application, and then each category of settings I would put there, but I would never put there updating actual entries, because the entries I would consider data, not configuration. So all I'm doing is, if I have a web application, I would have here every category of setting in a separate file, and I would just say, here create the categories, here create the models. This is just personal preference, but I think that just helps. That's one neat way to help a team track what they're doing. And the important thing is just separate the data from the configuration. Just recognize what is information I'm putting in that, and what is configuration that enables that to happen. So if you're adding some fields, that will be configuration. If you're adding entries which use those fields, that's data. All right, I think I don't want to run over the time. We're out of time for questions, so I will go back to my little slide thing. And do I still have it open? Okay, maybe I should share my screen. That would be better. Here we are. Okay, and I think we're at this point. The demo didn't blow up, so I'm like already. I'm like Hi. I feel like I earned the pizza and beer, you know? Like I feel that was the bare minimum to qualify for a slice of pizza. Don't blow up the demo. I'm getting more and more good at improvising random demos. You know, as I go along in this tech thing, it's just like, okay, let's do a demo. Let's see what happens. I think at some point we'll start blowing up again, but until I come full circle, that felt good. So yeah, quickly, I will just mention a couple more things about this, and then we can go into a quick Q&A. What more you can do with this if you really start, if you really have a use case for this, I think one thing is testing. There is a test framework. Essentially, it plugs in PyTest. That's what it's doing. It's called Ansible Test. There is some documentation on it. What you can do with it is you can really try to make this into standard software development workflow. Because I think a lot of what we're learning is you get so much benefit by taking what we've been doing in operations for years and applying knowledge that has been there in software development for decades. Like, you know, tests are not a new thing, but now we're just kind of realizing, hey, we can apply this to operations. It's awesome. And one thing that I'd really recommend, which this is very much so personal preference, but since this is live, shout out to one of my colleagues, Alex. Full integration tests where you bring up the entire development environment and you don't mock anything are really awesome. And in today's age with Kubernetes, you can really lean into this. And you can say, why would I mock an API where I can have a real live application to poke at? And I dodge all of the problems that way. Because I really get a consistent test result, I get a consistent environment. And, I really learned from a colleague who's really into Kubernetes, and he builds like beautiful, fully containerized dev environments where the devs don't even have an interpreter running on their machine. And we got rid of, you can just see the potential to get rid of so many problems. It's like, oh, here it works, here it doesn't. What's the inconsistency? If you turn down the container, rebuild it every time, it is consistent. Automating hardware. There is a lot of legacy stuff which we have to wrangle, like pfSense. There's a great example. The pfSensible modules on GitHub are amazing. There is still, they don't have everything, because I talked with the maintainer of them, and the way he said it, well, we publish them, but we mostly just cover our use cases, which is fair game to them. Great that they open source it. But if you want to have a look how to wrangle something that doesn't have a pretty API, we're doing live XML editing on the pfSense there, and then just hitting the PHP endpoint and praying that it works. And so far it works, so kudos to them. And if you want to look at some more existing code, you can look at this demo. There will be a link in the final slide, and you can run make dev. I promise macOS and Linux will work as long as you have Docker and Python. Windows, no guarantees, but I hope it will. But another well-established code that's open source you can look at, the AWX collection. I use it to manage my AWX at home. Amazing things. You can put the entire configuration of your projects, have it in Ansible modules, have just a little playbook, manage my AWX, run it, spins everything up for you, sets all your automation up. And now here's the quick Q&A slot. So if anybody has got any questions, should.
How do you handle imports of ELS, Python modules, and as dependency? How do you make sure that the requirements are met on other machines?
Usually wrapping it up all in a requirements txt file, and the way I like to execute my Ansible environments is always containerized. There was a great talk, I think we have a recording on Ansible Navigator. Amazing tool to run this. And the guy who did the talk, not only did he do this, but he did a great job of preaching running it not as root, but as a standard user, which warms my heart. If you need a way, if you've got the problem, because that's actually what I'm moving to it. Actually, the organization I'm at right now, we have the same challenge. We have a lot of playbooks which aren't yet wrapped in containers, and we see the problem where one guy runs them, he's very happy, it runs, the next guy runs them, goes like, guys, this is broken, your stuff is broken, gets really at us, and we're going like, well, it works for one guy, it doesn't work for the other, what's going on? And we just see that they have weird dependencies, weird systems, weird packages. So if we're talking about the way you execute it, I would say containerize it. It will pay off for you. If we're talking about the code here, how I track the dependencies, I just have a requirements file in my repository. All right. Anybody should?
You mentioned Ansible Navigator. What's that?
So Ansible Navigator, it's a great tool. What it lets you do, you can build a container where you bake all the dependencies in for running your playbooks. And it's a little CLI that will take your playbooks, put them in the container, and run them from that environment. So you can package all the dependencies for your playbooks, all the roles, you can install them, have them in Docker. It's also really useful for when you have an air-gapped environment, so no internet access. You can take all the collections, all the roles you need. You just run Ansible Galaxy once when you build the container, and then you can ship it all off to your developers, to your sysadmins, to whoever needs to run this. So really can recommend it. And we had a really great previous talk on this, where it was really, really good background. We had a guy from Red Hat come over. He knew his stuff. Red Hat guys usually do.
It's amazing because many of these things we did it ourselves by manual.
Oh, I feel you. I've been before I found out about it, I was wrangling dependencies. I was going like, "Oh, do I have the right Python version? Do I have the right module?" It was an absolute pain. So that was the best tool I got from coming to those talks here. Ansible Navigator can 100% recommend. And if you lay out your repo in a way that Navigator likes it, it also makes it easy for you to, for example, move to AWX, which also follows the same idea. You pass it a container as the environment where all the executions happen. So that's a more enterprisey tool. It's basically a web UI for Ansible where you can set scheduled runs from the API, and it's going to do this all on Kubernetes. It's going to spin up a little container, and the container is where you bake the dependencies, where you define this is what I want when this playbook gets run. All right, it should.
Yes, based on your experience, I mean, what is the benefit you see in using models here and compare with, for example, pure Python scripts?
So first, ease of usage. I work with a lot of teams where Python is not it's not a hard requirement. So, for example, our IT teams, we like when they know Python, we love it, but they don't always know Python. So we have some IT teams at one side where everybody knows Python. For example, Munich, we're quite familiar. And we have some teams where nobody knows Python. And what we want is, okay, we want them to be able to contribute, and YAML, you just lay it out. I pass this, I expect this. I pass this, I expect this. So it's simplicity. It's integration with more operations heavy stuff. So for example, if you have any backups you're performing and you're doing some, I'm taking a backup of a service, I'm restoring it somewhere, I'm migrating stuff around. If I'm doing stuff like this in Ansible, I also like to have modules wrapping such functionality because then I can integrate with other, let's call it operations heavy tasks. But if it's a simple utility, if you're a small team of developers and you all, are familiar, just need a utility to do something, I wouldn't bother. I think this is more where you really need to give people something that's useful for non-developers, and it's useful for tracking configuration, like discussing on configuration. So one example would be like, we have this giant web application, and in it you can define basically arbitrary data structure. You can say there's a little field here, and in this field you can input data of this type, and here's the possible types of data you can input there. And we've had a couple of times mishaps with this, where something got implemented that you didn't expect to be implemented. And if you get a culture of people, sharing this, discussing on MRs, keeping the discussion there, it helps to keep things like this consistent. So I would think about before I develop anything, because it's a cool thing, but you can add, you can add overhead because people have to get familiar. How does Ansible do things? So if you have a team that has one small use case, probably not worth it. If you have a growing organization that starts to have something get out of control, and you really need people to define it in Git and keep it, and you think it's a configuration management system feels like the right place for it, then I would go for it, for Ansible. Yeah, absolutely. I will, like, if of course, I'm lazy, so the first thing I'll do is I'll go on Ansible Galaxy and go like, did somebody do this already for me? And if they did, I'll just use it. But if I have a use case, like for example, if I use this inventory system, if I use it at a bigger scale with a lot of companies involved, and I want IT teams to be able to make changes there, but I cannot expect them to know Python, then I would go, okay, let me develop some modules and pass that to them, and that's just set a workflow with this. Or if I have a weird firewall model that I need to manage, then this is the way to do it. All right.
If there are not any more questions, Daniel, thanks a lot.
Thank
And, we have a little gift here.
Yeah. Oh, from Red Hat, we want to give you a bottle of red. Please.
Thank you, sir.
Hope you can enjoy it. Thank you very much for your contribution.
Thanks. We appreciate it. Hey guys, we're gonna have a break for pizzas and talking, and then next talk with Joachim after the break.
Okay.
Okay. Thank you.
So if you want to actually want to live here in the Netherlands, I didn't. I was not doing this. All the libraries give you everything except for the recall. You don't have that.
Talking to him.
I think it
Oh yeah, I remember.
And it makes sense because you see a lot of the guy who was like, and is it about so you know, and that's community
Check.
all your grandparents I have a feeling to see it I know I actually got the question. Sorry, where's one of the worst, but still part of this.
Just sort of okay, but it doesn't work sometimes. Just to everything and share
Darfst du auch noch einen Vortrag halten? Hast du ein Pausenbild gerade aufgelegt, oder? Die Werke zerstört, cool. Einfach oben eingeben. Ja. Mummel, Mummel. Meine Rücken. Das ist die echte Zeit, oder?
He likes it. They don't know they like it.
Oh no, but I don't get Oh, really? I can't believe whatever.
Ja, also yes.
Okay, who's next?
Okay. Haben wir zufälligerweise ein HDMI auf was auch immer das ist? Ich habe nur USB-C. Guck mal, vielleicht hab ich mal.
Geht das nicht hier?
Nee.
Könnte gehen, du. Das sieht so aus, als ob es für Video ist.
Ich habe wenig mit.
Nee, ist nicht für Video. Nee.
Hast du vielleicht USB auf HDMI? Ich weiß jetzt gar nicht.
USB-C HDMI.
Ein Adapter, ja, habe ich. Soll ich holen?
Ja, ich gucke gerade, aber ich glaube, ich habe den auch nicht dabei.
Braucht ihr USB-C auf HDMI?
Oder?
Ja.
Nein, das ist USB-C auf USB.
Ist auch schön. Okay, dann laufe ich kurz los.
Ja, klar.
Super, danke schön. So. War alles sehr überstürzt. Der Mihai ist total versemmelt. Er hat mir gesagt, das ist ein Hawking.
Will tell us about Ansible in industrial systems.
So,
This is yours.
there you go. So, let's start. All right, guys. Good evening. How you feeling? Was the pizza nice? Are you ready for another talk, or make a small break? No breaks for you. It's not a big. So today I wanted to talk about a project I have. I have to talk a little bit about it in an abstract way. It has a few reasons. I'm also an MBA and so on, but what I want to show you, not this, what you see right now, this is just what I have opened in my IDE. I want to show you or explain how Ansible works in, let's say, industrial environments. Sounds a bit, let's say, big, but it's kind of a journey, how you go from development, to the factory and beyond, basically. So, but before I start with it, I have noticed there's a lot of interest regarding Ansible in containers. So I will basically start with what I intended to end with and show you a small alternative of using the Ansible Navigator. The reason why I was doing it like that is simply because the Navigator is a bit opinionated, and I just show you a small thing, nothing special. So basically, I also use Ansible containerized because, well, dependencies and such things are exactly the reason, and also versioning of Ansible, which is often a problem, and maybe you want to install specific packages because you need maybe sometimes things that Ansible modules do not properly support in any form. And more or less, that's my Docker file for this one, which is simple. You can build on top as much as you like. And I actually use it also as a command line and drop in. You see there's no entry point or no command call at all. And I show you a little bit why. And the nice thing is, again, it works in the pipelines the same way it works locally. It works on the servers the same way it works locally. You have the same thing all over again. So what I'm showing you here is now, first of all, this little thing. So I have a set of aliases. You can do it in two ways. First of all, I explain it a little bit with a bash RC or a ZSH or however, whatever you're using. You have a function that more or less, the name of the function is Ansible. This function has a few defaults. I have here this empty array for TTY flags. I come to that because every environment has a TTY. Here we have some fancy stuff. Shell has a TTY. If the shell has a TTY with standard input, I set and I append I to the TTI flags. If the shell has a std out, I append T to the invocation. And if the array has any items, I create basically the command line options for it. And well, this one will be explained later when I scroll down. Here I just make sure that the invocation or check if the invocation was not empty and pass remaining arguments to the call. And here also I have a small alias for me. I call it Ansible shell, so I can just execute an interactive shell if I want to debug something inside the Ansible container. So when we scroll down a little bit, When I scroll down a little bit, you see, now we run Ansible in a Docker container. You can also use Podman. I also run it rootless and as my current user, so I don't mess up permissions when I write stuff or read stuff from that. So what I do after container ends, I remove it. Oh, by the way, first here the TI flags, -i-t, who doesn't know them. Then we have rm, remove it, and I pass my whole environment to it, because sometimes I do need environment variables like tokens and stuff that some modules will use. I just attach it directly to the host network. I mount the temp volume. I use this sometimes to share output between the container and the thing. I mount my password as read-only, so it knows which user I'm using. I mount basically my current directory to the current directory, set the current directory as work here. I mount the Docker socket, so I can also do Docker stuff within my Ansible container. And then I mount a temp attest for the Ansible temp files. So I just throw it away. I don't want to store that stuff. Then I set basically my user and group, which I'm currently logged in with as the thing that runs the container. Here, this is a variable. You can name your build however you want. We call it Ansible variants or Ansible latest or whatever. I append the Ansible command, which is the first parameter of this of the whole parameter group. And that's it. And this execute, it just behaves like as you would have Ansible installed locally on your system. Magic. Well, and that's how I invoke the other commands like Ansible Vault, Ansible Playbook, Ansible Inventory, and so on. But wait, there's more. So you basically also have often the environments where you want to invoke Ansible, like with a cron job and so on. And this is a playbook I have used. It's more or less builds the Docker container, blah, 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 blah. But we have a really fancy thing here. I read actually this shell script into a variable. Where is it? And here, you see, I'm just creating files and use the local bin, which execute this command. So if you run cron, you don't rely on your profile. So you can just run the container as it would be installed. So that was just a little pickup from him and an alternative to the navigator. Any questions about this before I proceed? Okay.
It looks really good.
Thanks.
It's a very interesting approach. It's on GitHub.
No, it's not, but I can put it on GitHub actually. I said I didn't think much about it when I did it. I just tried to solve problems. You know, as usual. So let's go to the presentation. So let's do this full screen. So I must admit one thing. This time I do wrong console. This time I do not do a demo. I had some time constraints as well. So I'm mostly discussing some concepts, explain a little bit what we did. And well, if this, let's go through this. Ansible and industrial appliances. Well, let's, what's an industrial appliance? An industrial appliance could be anything. You know, it could be display which is mounted somewhere. It could be some CNC machine where you have an embedded computer. It could be some other systems like audio systems that needs to run autonomously. Everything that you basically, every appliance which has basically a computer in any form inside. So this comes with certain requirements and challenges. Vendor usually requires a way to achieve reproducibility, and during the whole development process, the people need to work against a system like this. And as Daniel previously said, it's really nice to be able to throw away and start from a clean slate to work with this. So another requirement is that you see, when you have such a system, you have kind of an assembly line. Let's say you are building CNC machines or displays. You basically get from your hardware partner, lots of devices. Then you in your facility, you must unbox them, you must set them up, place them into a system, connect it, and then ship it to the customer. And here, the more interaction and interference you reduce, the more time you save. That's money. Simplicity. So in this case, we don't use any special or non-standard solution. We actually use Ansible, and maintenance and knowledge build on industry standards and enables easy knowledge transfer. Knowledge transfer is important. Just as again Daniel said, I can only refer to him all the time because he already said many important keywords. We have a team of people then with different knowledge domains and so on. And the more complexity and more tools you add to a specific environment, the more complex it is to understand. So, well, what we use Git and CI/CD. As said, you can basically, it does not matter which tool we use in this environment, but this works with all kinds of CI/CD tools, like Jenkins, Git, GitLab, GitHub, Bitbucket, does not matter. So when we use this tool, when we use a process like this, we can deploy changes. When someone commits to a repository, for example, we can execute jobs and monitor the provisioning jobs on events. Usually, I don't use an UI specifically for Ansible, but I just use the CI/CD tool the teams have, like whatever, and they usually have an UI, so you can just look into the pipelines. So you see what's going on, and you can generate reports. And yes, visibility during the process in the end. All right, how do we do it? So as said, this is basically a factory of an assembly line. So how can you even provision boxes? We decided on using a Pixie server as a means to do this. That means they have an on-prem system, and we have kind of a plug-and-play approach on this whole thing. Basically, you plug them in, and they get provisioned. Good. So here they get the ship from vendor, unbox it, put it here, plug in, power on, that's it. So, plug and play. Pixie stands for pre-boot execution environment. It means, most of you will know what a Pixie server is. So I'm basically just repeating it. So you can boot an operating system from the network. And we have decided for a simple approach. You see? And what I said, okay, you just plug it in, it boots from Pixie, and that's it. What you need to create first is a mold. You have many of these industrial PCs, and how we work is like we have one system that acts basically as the form, where we say this is how we want it later, and then later we have deployment targets where we write the images to the system.
Just out of curiosity, do you rely on DHCP?
Yes, in this case, it's an isolated network.
Okay.
Here, this that I come also later to that template host has a static, is for us a static system. It has a defined MAC address where we know this is always the same IP. Does not matter. The deployment targets, they come and go. I don't care about them at all. And here, this is where my mermaid diagram is broken, which I tried to embed into Slidey. I just need to press refresh, and it's working again. Okay, so basically that's the architecture. We have basically our source code management, and we have our on-premise Pixie server. On the one side, we have basically a factory repository, and in this factory repository are pipeline definitions. And on the Pixie server, we have a Docker container, which has a pipeline runner. That, as I said, could be any build agent, does not matter. And this pipeline runner is registered to the SCM and can act on its calls. You see, even it does not matter if it's intranet or internet. These systems are often separated from each other, and that's right. Because there's also different responsibility of maintaining and running them. And basically, this kind of builds a bridge between them. And also DHCP, the templating host, we create an image on the deployment target, we write an image. So And again, I need to press F5. So this is, for example, this is now a workflow, how we start the execution. Basically, this actor, it could be a developer whatsoever. He triggers the pipeline in any way. It could be a manual click on the front end. It could also be a code commit. The SCM sees, all right, I have a change. I have a condition in my pipeline definitions where I say, hey, update the Pixie server. This is for the templating host line. Triggers it. The pipeline is being executed. We use the runner installed on the Pixie host. We put repo contents, and here that's where Ansible comes in. It also, the pipeline runner also, in context of Ansible, sends a wake online on the templating host because you can keep it off if you don't need it. So it sends the wake online, it starts, and it boots from the Pixie server. The DHCP server has usually the ability to execute scripts to perform callbacks. And we use this mechanism to perform a callback basically to the SCM. I'll come to this in the next slides, and execute the next pipeline. But this has time. We have to wait a bit because we also perform an unattended install. But so anyway, callback executes a defined pipeline with CI/CD. Pixie server has again this local runner which will be reused, and more or less it works like this: that when the callback is sent, means the event is in our case transferring the init.rd image. And where is it? Exactly here. We said the arrows are missing, but we sent back the callback to the SCM. It leads to a pipeline execution, and this Pixie server executes basically the Ansible job in the pipeline runner for the template host, and until it can work, it waits for connection. There's this Ansible built-in wait for connection module, which basically waits until the unattended installation is finished, which is doing it. Unattended installation, I don't know if you had some experience with that. Most operating systems do offer a way, if you provide, let's say, a user data file, or how is this being called with Debian? I used it a few. Pre-seed, exactly. Using the pre-seed configuration, or in Windows, unattended XML. So basically that's being executed. And while this is running, we wait. Theoretically, we could do anything there. No, we cannot. Sometimes you need an installed operating system to perform specific tasks and do also specific cleanups, set it to a specific state. And that's what we do with Ansible here. So now what we do in the unattended installation is usually partitioning, installing the operating system, perform OS and security updates, configuring an initial user, reboot, and that's it. There's nothing else to do, because the rest, we have a better way to do it. So after reboot, the SSH connection becomes available, as said previously, and we perform the remaining tasks. We do software installation, because that's a very important point. We have, I said at the beginning, we have a whole application lifecycle, where there's a development process, where there's a research, a factory process, and so on. And no one ships just a system with a computer. No, they often have their own software running in this embedded device to perform, well, the task that the appliance is made for. And also some host behavior stuff, like hardening, configuration, recreating host keys, and so on. So, well, what happens after that? After these tasks, we unmount the root partition, we change to a chroot environment. We use very simple technology. We use DD and gzip to read the disk, write it to an image file, and upload it to a file server. Just like that. So when the task is finished, by the way, you see, we don't want to touch that stuff. Task is finished, dd, if f0 of the SDA bs1n count equals 1024. What means it? We just write a set of empty of zeros for the first gigabyte to the disk. So the next time it starts, I wanted to boot from Pixie again. That's why you have this break on none. Otherwise, we would even need to change the BIOS settings or the behavior for the Pixie server all the time. And so this way, we kind of avoid this hassle. So, deployment targets. What I described now is the system where you deploy the configuration for the future deployments. What you have now is exactly that step which I described you. You unbox it, you plug it in, be happy. So, again, in the Pixie server, we have basically two configurations. One static MAC ID. I said I'm not sure how familiar you are with Pixie servers, but you can have various configurations for different hosts, which could be identifiable by MAC ID, and you have a default. And the only thing that keeps that MAC ID configuration as a templating host is the deployment target's default. No matter what you connect, that thing will happen. So the deployment will be triggered when you connect it. The same thing, it would be the same diagram. What happens now? It boots, the DHCP server performs a callback. You have a small OS image, which just downloads the current latest image locally and write it to the root partition of the host. So, right, and partitioning is happening as well, because this has a specific layout. I come to that a bit later. When you have written to it, then you are done. You have a new, then there are some final steps. That's why we call Ansible. Like you see, this templating host has a little bit of clutter when we create this image. That means there is some remaining logs, configuration, and so on. And what we clean up is like deleting a host fingerprint, create a new one, creating with users, passwords, and keys specific to this system. That means no. These systems do not have all the same password. Or the same certificates or keys. This is not like it. Well, we execute also some functional tests and reports. We say we check if the container were all properly started. We check if the application is behaving well, if all system D services are fine. And well, we basically prepare the factory state. Factory means we clean up all the remaining stuff to have a pristine state. And more or less, then it's off. Then they can take it and put it to the next part of the assembly line. So, in case I talk too much, that's just the short point. Ansible is used to provision a Pixie server on-site in the facilities. Infrastructure and code is managed in Git repositories. The CI/CD pipelines are used to update the Pixie server, the deployment, and the Pixie server is responsible for provisioning, templating, host, and deployment topics. What did we achieve with this actually? Well, when do you need manual interaction? When do you need to interact with the template host? When do you need to interact with the deployment target? How long would the process take if you do it manually? We guesstimated around 2 to 4 hours, depends. And you can mistype and do mistakes. And how much time you save when you have 100 systems you need to provide? 400 hours? You can provide proof for the entire installation process. This is important for claims. We can always prove this system was shipped. It left our facilities in this state. It has this software packages. That's important for compliance, like proof of the software inventory. We can provide with tests that it was working. You know, shipping damages, anyone? We achieve that you can always look into it, what's happening. And we have a complete history of changes, what was done in the code and who did it, if you need finger pointing. Well, and of course, the automation is for me also documentation. This is for me the same thing. Automation provides documentation, and I cannot emphasize this enough, because you can see exactly what every step is doing. This is for me one of the greatest benefits, actually. So again, prolonged rate deployment targets is provisioned by writing a disk image from the templating host. The callback to the CI/CD make the provision and jobs visible and traceable. Ansible is used to finalize deployment. The system is then tested prior to shipping. But what happens beyond the factory? So this thing leaves my premises. It's no longer my problem. No, you are responsible for that appliance. You know, you have a software lifecycle. Yeah, but what should I do? I cannot update it. It's air-gapped. It has no internet. Well, you see, in the factory, you have all your networking connection, you have L packages and such appliances. As said, they run usually in air-gapped environments for various reasons. And we have here some synergies, like we use an image. There's a reason why we didn't decide to go for an unattended installation for everything. And the image has a specific state. And this image, and we only use the root partition image because the other partitions hold actually the data. They are symlink. And you have, so basically, when you have now a term where you need to update the systems or the field service, he just goes there with a USB stick with the image, plugs it in, db, if dev file of SDA1, done. Oh, you want to factory reset your application? No problem. For some reason, someone fooled around, managed to break something badly. You just use the same image to go back to factory reset. Well, the image is not that big, actually, because I said with the partition scheme, it depends, of course, of the appliances, what they need to run, if they have media, if they have databases whatsoever. Here, you just take care of the bare minimum root installation, and this is exactly how we solve this problem. Again, also the image has a specific state. If it's an update, you know, it is exactly what you have tested in your development on the same environment. Yes, it's not all fancy with clusters and clouds and Kubernetes, but this is how you can apply it basically for enclosed systems. And it keeps the processes unified. There's no differences between it. The process is always exactly the same. So, factory and field service uses the same process and artifacts in the end, except that the field service does not run Ansible, Pixie, and all the stuff, but he gets the image. Knowledge transfer is easy. It's really simple. You don't need to run 15 tools with 20 different steps involved with a 500-page handbook. You just have one page that explains what kinds of commands you need to enter. There's no third-party or Snowflake solution if you consider Ansible third-party, but the image, MDD, is out of the box of your Linux box. Upgrades can test it easily. The operating system can be swapped. These air-gapped environments and the vendors have often the demand for long-term support. I'm not a big fan of long-term support, actually, because it's more than it's usually a big hassle to maintain software on old systems. I hear that often from embedded developers. They have some very old operating system, and they need to implement a new feature. And to make this feature working properly, you need new versions of library, and then you need to build dependencies yourself. And then again, you don't use them from the long-term repository anyway. So here, install a new operating system or distribution of whatever. If you notice your current operating system does not work for you, then you can just replace it. That's it. What? Any questions? Thank you.
When do you wipe the device?
Is
it because you're testing different versions of software on the same physical device?
Yeah, yes and no. Okay. I wiped the templating host because I forced it a little bit to always reach a specific state and boot from the network instead of reconfiguring it. What is wiped is basically the disk of the templating host, which acts as a mold or form for the other systems. And I do this after I have created an image.
How does the PXE server know? The templating host is obvious. It has always
That's a MAC ID. Yes.
it has always the same MAC address. But say you have notebooks and small embedded devices, which both should be provisioned. How can you differentiate?
Okay. Yeah. Let's say this approach might not be ideal when we talk about office supply deployments. There are better tools for that, like OPSI and whatsoever, and other approaches. Here we're talking about facilities which only have very little differences in hardware, and even if they have different hardware, it might be just CPU and memory size. It's basically, now we have the PlayStation 6, you ship 1 million devices, and they are all the same. Okay. Exactly. This is why this approach was chosen.
Yeah, but you still have local disks, and you just use the image for booting and mount everything else on top of that. How this is working, or is it just some?
They all have local disks. As said, these are industrial appliances. They will be shipped at some facility where they are maybe not networked, maybe they are networked. We have no influence about it. It can go to an oil rig, to a ship. Don't know. And basically the disks have the local, the devices have the local storage. And that's why we're using images. We have a partitioning setup, which has multiple responsibilities. Like we have one root partition, we have one data partition, we have a backup partition, and we have a factory partition. And maybe you noticed it when you also have your regular laptops that HP or Dell likes to hide some backup or factory partitions to restore back the system in a pristine state. Same thing what we do here. So this is how it works, and that's and also in Linux you can usually use different folders and disks for different mount points. I mean, that's the whole reason why this POSIX layout exists, because it was back then all on disks, and more or less this is the same.
Okay, but you use PXE and DHCP and stuff like that only for partitioning stuff. After that, you have probably static IP addresses and
no.
static things on the disk. Or?
No. The PXE and DHCP stuff is for booting them. You see, when you do it manually, you would need to take this device, put it here, and put in a keyboard, put in mouse, put in a screen, take a USB stick, press F8, and so on, and do all these steps. And here from this PXE boot, you basically just plug the network in, and that's it. It starts the operating system, and the part is when the operating system is booting, like for the templating host, we install an operating system in an unattended way. You can give, as said previously, Debian has, for example, a preset file. Ubuntu uses user data. I forgot what actually Red Hat is using. Windows uses unattended extender. Huh? Kickstart. Ah, yes. It was the same name with. I think Solaris used Kickstart back then too. It was the same name. And I always have to think about Amiga Kickstart. Anyway, you have a file which defines what should happen during the installation process. And this is the responsibility of the unattended install. That would be creating the initial partitions, initial user, but nothing too much.
Yeah, I was just curious because the most lines in these environments I know don't have DHCP. So DHCP is just used for provisioning stuff, and later on everything is static.
Yeah, okay. Let's the static IP addresses. As I said, we are still at a facility. We have a factory state. Networking configuration and such is done when the system is shipped and set up. This is part of the appliance, so to say. They have often a user interface or any commands you need to enter to configure the IP address. Or maybe what's also often the case is that they come pre-configured with a static API, so you can access the net, the setup screen and stuff like that. Same thing here. It's just not part of my problem in this case, because this is just the how do I get it to in a reproducible manner so I can supply easily thousands of systems for, as I said, for the industrial appliances. You can actually use exactly the same mechanism if you run your own data center. You could basically also, or I mean, that's actually quite common, that you have one Pixie server, and all network and all the operating systems are booted from the network, which then come more or less pre-configured whatever you need. If you have a VM installed, maybe a Kubernetes agent, which is network booted and joins the cluster automatically, that's the same concept.
Thank you very much.
Yeah, in the end, with Ubuntu, it's cloud init. It's exactly this.
The OS is made by the cloud init.
No, Debian has preseed usually.
The cloud init is if you have an image and it's configured while you start up.
Yes, that this is the agent that's
running.
running.
It doesn't have to do anything with Kickstart or with
no.
Just or whatever.
That comes after all this. This comes after all this. But Ubuntu, funny thing is using cloud init for the auto installer. Yeah, it's just.
Any other apps you can also download cloud init versions. It's configured and it's just an image and you configure that. But it's probably different.
Yeah. So, any other questions, or maybe something I can show you?
So, do you ever run into challenges migrating state between versions? So let's say you mentioned you have separate partitions, right, for all the state, and I'd imagine it holds some configs as well. And do you ever have a problem where an application might have database migration, but let's say there's a breaking change in the config compatibility? How would you approach this, or is this enough of an edge case that just has it off?
It's not an edge case, it's common. And the thing is, actually, it is part of also of the development team, because when you, for example, when you create a new script, and part of this image, when you create a new image, you should also make part of that image a script or whatever to check which versions were previously, which configuration versions you had previously, so you can execute the correct commands prior to starting the rest. That's true. But you will have this always. This is always a difficult thing, but you can configure a compatibility matrix. If you version your Git stuff correctly, when you use version tags, if you're using a versioning schema, then you can also basically create a versioning matrix. And yes, even if one has not updated for 8 years and now the new version comes, then the step is he does not bring one USB stick, he brings 8. No, actually a small disk, and like the images are not that big, they fit all on this, but basically then you have to do the updates in a procedural manner so the compatibility is ensured. And I'm surprised, it's actually how you need to do it all the time, exactly for this reason.
All right, guys. Joe, thank you very much.
No problem, thank you. Thank you. So.
Danke dir, Joe. Schreibt mir wieder roter Hut, roter Wein.
Danke schön.
Dieses, ich hoffe, es passt.
This concludes our technical talk, and feel free to network, and it's open-ended, and we need to finish everything what's in the fridge. And thank you for joining.
Thank you.
Thank you.
Because my